The early jet airliner de Havilland Comet suffered multiple catastrophic mid-air breakups in the 1950s, which were later traced to metal fatigue caused by repeated cabin pressurization cycles. Each flight pressurized the fuselage like a balloon, and stress concentrated around square windows and cutouts slowly grew cracks that were invisible during normal inspections. These failures proved, for the first time, that pressurization is not just a comfort feature, but a dominant structural load, and that repeated pressure cycles can destroy an aircraft even when it appears strong in single-load tests. The Comet accidents fundamentally changed aviation by introducing fatigue testing, round window designs, and the modern concept of damage tolerance in pressurized fuselages. In 1988, Aloha Airlines Flight 243, a Boeing 737, suffered a dramatic fuselage rupture at altitude when a large section of the upper fuselage tore away during cruise. The investigation revealed that thousands of pressurization cycles from short-haul operations had caused widespread fatigue cracking around fuselage lap joints and window areas. Although each individual flight imposed normal pressure loads, the repeated pressurization and depressurization slowly weakened the structure until it could no longer carry the load. This accident highlighted that pressurization fatigue is cumulative and unforgiving, and it reinforced the need for damage-tolerant design, strict inspection programs, and residual strength requirements to ensure aircraft remain safe even when cracks exist.